Cool. All right, guys, let's have a look at this practice test. For question 1, we are asked to find the length of the hypotenuse in these triangles and round to 2 decimal places where appropriate. The fact that we have information on 2 sides and no angles is the prompt for me that we're using Pythagoras and not trigonometry, okay? If I went and had a look at my page of notes, it would clearly state for me this formula here, right, which we should be familiar with from class. It would also say that one of my first steps is going to be to label the triangle in the question. They've actually already given us C as the hypotenuse, which remember is diagonally opposite the right angle. And then in this case, when we're finding the hypotenuse, the other 2 sides can be A or B and A. They have the freedom to swap in this case. So that's absolutely fine. We are now going to make the substitutions. So I'm rewriting this equation exactly as was, but instead of the letter A, I'm going to put in the number 8. So 8 squared. And then instead of the letter B, I'm going to put in the number 6 squared. And then I will get my calculator out, put that in, and that will give me, cool. Sorry for the interruption there, guys. That will give me 10 by putting exactly that into my calculator. Very similar story with this next question. I'm going to label my sides. Hypotenuse, or C, is already given to me. Just a reminder that it's diagonally opposite that right angle, or it's the longest side. And then A or B would be fine either way. Same as before, I will start with my formula. Okay, very important. And then I'll replace the letters in my formula with what I've labeled on the triangle. So A will become 24, and B is going to become 7. Putting this one into my calculator, 24 squared plus 7 squared, we get 25. Awesome. All right, last one over here. Labeling this one C, A, B. Once again, A and B could be swapped. C is going to be the square root of A squared plus B squared. And in this case, A is going to be 12 and B is going to be 5. So we get 13. All right, next questions. It asks us which ratio would we be using to solve for the unknown value in each of these triangles. That is hopefully very obviously trigonometry, right? They're using sine, cos, and tan, which is trigonometry, right? So we should be quite familiar with that by now. If I'm looking at triangle A with trigonometry questions, the first step is to label it with opposite, adjacent, and hypotenuse. With respect to hypotenuse, it's still diagonal to that right angle, this side's hypotenuse. Then if I'm looking from the 12, with respect to the 12, the other side with stuff written on it, because this side here is blank, right? So we don't look at that side, but the other side with stuff written on it with X meters is opposite. It's the way that that angle is facing, so we would label that O. Given I have O and H, if I use Sokotoa, like I said, our favorite little jingle, for a little while, you can see in So, it's not letting me draw on top of that picture, but you get the idea, guys. Sokotoa in So, it's got O and H, which means that we're using sine. Okay, so sine of theta. For this next one, the hypotenuse side would be diagonally opposite the right angle. It is unlabeled, so we're not going to mark in that that's the hypotenuse so that we don't confuse ourselves. We're then left with the way 60 is facing as opposite and with the side that 60 is touching as adjacent. With opposite and adjacent in TOA, in TOA, we have O and A. In our triangle back over here, we have O and A, so we're using tan. Last one here, we've got the hypotenuse side there. It's diagonally opposite. And this side here is touching the angle. It is not facing the angle. So this side here is adjacent. With A and H in Sokotoa, A and H can be seen in the Ka. So we have cos from Ka. Because remember, the C in Ka stands for cos. Okay. All right. 2 questions down. This one's going to take a little bit of a while. The first thing we need to do is same as before. We need to label our triangles. So 54, that's going to be opposite. That's going to be hypotenuse. with O and H, we are using sine. So I'm going to be using for part A, let's do part A down, let's do part A down here. So I'm going to be using sine, and since I'm finding, it's asking me to solve for the pronumeral, right, which is the letter X. So since I'm trying to find X, I'm going to use the opposite side. I'm going to say that's equal to, I'm going to come back to these labels here. I've said I'm using sine. I'm going to cover this side here with my finger, and I'm left with these two parts of the pyramid, right? When they are sitting next to each other, that is times. So we're going to have sine of the angle times the hypotenuse side. We're going to get the opposite side is X. The angle is 54. And the hypotenuse side is 14. Putting this one into my calculator, I get sine of 54 times 14, 11.33 roughly. Okay. All right. Part B, we'll do that one over here. Labeling my triangle, the X is opposite the 26 and the 10 is adjacent to it. With O and A, I am using TOA or tan. And if I have a look at the triangle, the unknown side that I'm trying to find is X, which is on the opposite side. So we're going to write opposite equals. And then coming back to tan, if I cover the O, I'm left with tan and A, which once again is multiply when it's like that. So we're going to get tan of theta multiplied by the adjacent side, right? That's come right from this triangle where tan and A are next to each other, being multiplied. The opposite side is X. Tan of the angle is 26, and the adjacent side is 10. X is going to be equal to tan of 26 times 10. Put that in the calculator. About 4.88. Okay. All right. Next up, let's do part, just because I'm going to try fit it so that everything can still be seen. I'm actually going to do part E next. I know it doesn't make much sense, but just because it's closest. Actually, no, I'm going to do part D. Part D next. All right, part D. This one here, we have opposite and hypotenuse. O and H, if we look at our pyramids, is sine. I am solving for, in this case, I'm solving for H because Z is the pronumeral. So if I cover H, I'm left with the O and the sine, which across that line is divide. So we're going to get H equals O divided by sine of theta. We're going to get H equals, the opposite side is 5, divided by sine of 29. Just wrap that in brackets. And we'll put this in the calculator. 5 over sine of 29. We get 10.31 roughly. Cool. All right, so I've done A, B, D. Next, I'll do part E over here. Labeling part E, I have opposite and adjacent. Then if I go to my trig ratios, I'm going to be using tan. And in particular, I'm solving for the unknown angle. As you can see, the angle is unknown here. So if I'm looking here, I'm covering this one here because that's the angle side, which means that this bit here would look like that when I'm covering it with my finger. So I actually have the O over the A, which is divide, remember? So we're going to end up with tan of theta equals opposite over adjacent. Making my substitutions. Opposite side was 11, adjacent side was 9. And obviously we're not trying to find tan of theta, we're trying to find theta. So I need to move this tan across to the other side. And to do that, we do the opposite of tan. So remember, opposite of times is divide. Opposite of tan is tan inverse, or tan with a little -1. So moving the tan across, we get tan inverse of 11 over 9. To put that in the calculator, I'm going to have to press shift first and then tan. And we get 11 over 9 inside of the brackets. which gives us 50.71, and we're always measuring in degrees with our angles. All right, I admittedly am running out of room a little bit for part C and part F. We will try squeeze them in. Yeah, we'll try squeeze them in a bit later. I think you guys have got the gist of it. We've actually done one example of each type of trig question. So we haven't done C and F yet. I will do them at the end of the video. Okay. All right, for the TV screen, it's got a size of 63 centimeters across the diagonal. The vertical height of the 63 centimeter screen is 39 centimeters, it says. So to me, that's the vertical height there. And we want to know how wide the screen is. Well, how wide it is would be that distance there. So we want to find that. We know that this bit here is 63 centimeters. We know that bit there is 39. What do you know? That's a right angle there in the TV because it's a rectangle. Now all I have to do is find x. Hopefully we can see that this is, because it's got two sides, we're going to be using Pythagoras, not trigonometry. Okay, there's no angles being talked about here, so it's Pythagoras. If we have a look and I label my sides, diagonally opposite to the right angle, I got C here. And then when I'm solving for one of the short sides, right, because x is on one of the short sides, not the hypotenuse, I want to label that side B and the other side A. So that now when I use this formula, b equals c squared minus a squared, I can put in, instead of c, put in 63, and instead of a, put in 39. Once again, I would have got this formula here from my notes if I did a nice page of notes. And then substitute that in to my calculator, or just put it into my calculator. I get 49.5 centimeters. Okay, final answer. All right, we have a boat anchor question here. So one end of a 12.2 meter rope is tied to a boat. The other end is tied to an anchor. So this rope is tied to the boat and to the anchor. If the anchor is making an angle of 34 degrees with your vertical, how deep is the water? So when it says how deep, we're trying to find this distance here, right? So that's my unknown side there, x. And they've dotted the line in to make us a triangle there. So I'm actually just going to redraw this here so that it looks like some of the triangles we're a little more familiar with. Okay. So this angle in here is 34, and then we have 12.2 meters out here. If I was labeling this diagram, I would be able to see that diagonally opposite to the right angle is the hypotenuse, and then adjacent to 34, we have x. With A and H, we're going to be using cosine, and I can see I'm trying to solve for the adjacent side because we have x there. So I'm going to go over to my cosine pyramid, and because I'm trying to solve for the adjacent side, did we say the adjacent side? Yeah, the adjacent side. I'm going to cover the adjacent side. I'm left with cos theta times, remember across this line it's times the hypotenuse. So coming back over here, we've got the adjacent side equals cosine of theta times the hypotenuse. In this case, theta is going to be 34 and the hypotenuse is 12.2. Cosine of 34 times 12.2 in my calculator gives me 10.11 meters. Cool. All right. Ooh, tough one. This one we've got two triangles sitting on top of each other, and we're asked to solve for x, right, which is an angle. And if I was just looking at this top triangle on its own, I don't have enough information, right? I have x there and 10 there, but I don't know anything else. With just one piece of information, I can't find x. However, if I look at the triangle below it, I've got 3 centimeters and 65 degrees. I have two pieces of information. Now, what do these two triangles have in common? Well, because they share that side there, this base and this top bit, they're the same length, right? Even though I haven't drawn these triangles to scale, you can see that those red lines all came from each other. They all match up. So if I find the length of this side here, it'll give me the length of this side here, which will help us find x, right, which is the end goal, remember. So coming back to this triangle here, I need to label it. I'm trying to find this side over here, which is opposite, and I have been given the adjacent side. This is going to be tan from the TOA section. Because I'm trying to find the opposite side, I would cover the opposite side, and I would end up with tan of theta times a, and that's what the opposite side is going to be equal to. And so the opposite side equals tan of theta is 65, the adjacent side is 3, opposite side is going to be tan of 65 times 3, 6.43 centimeters. Cool, which means if I redraw this triangle here, again, mainly for your purposes, the base is now 6.43 centimeters. That bit there is 10, and we're trying to find x. With respect to x, I have information on the adjacent and the hypotenuse side. Adjacent and hypotenuse, that will give us cosine. In particular, we're trying to find the angle. So when I look at my cos triangle here, I would be covering the angle, and I have a over h, which is divide. Okay, so if we go back, we end up with cosine of theta equals adjacent over hypotenuse. Right, in this case, theta is x, right? The angle is x. Adjacent side is 6.43, hypotenuse side is 10. Remember, opposite of cos is inverse cos, same way that it was with that tan earlier. So we do cos inverse of 6.43 over 10. We would get, putting this in the calculator, once again, I have to hit shift before I hit cos to get the cos inverse. I will get 49.98. 49.98, and our units are centimeters. Lovely. All right, this is a big test. All right, next question. From a point on the ground, Abed measures an angle of elevation. So point on the ground here, he measures an angle of elevation of a 120 meter tower. All right, so my tower, it's 120 meters tall. And the angle of elevation is 34 degrees. So angle of elevation means up. So the angle going up from the ground is 34 degrees. How far from the base of the tower is Abed? So how far from the base of the tower? That's the base of the tower there. That's Abed there. So the base is that distance from there to there, which is what we're trying to find. If I was to redraw this situation with just a basic triangle, right angle there, my building's 120 meters, x and 34 degrees in there. Labeling my triangle, since I got an angle, it's trigonometry, so I'm going to go opposite and adjacent. I'm trying to solve for the adjacent side, so when I cover up my tan angle, I get O over tan of the theta. So adjacent equals O over tan of theta. Making the substitutions, 120 over tan of 34, which is equal to, on my calculator, 120 over tan of 34. Probably should clarify that this 34 needs brackets around it, and we get 177.91. All right, what have we got left? Two more questions. Next one here. Power line is stretched from a pole to the top of a house. The house is 4.1 meters high, and the power pole is 6.2 meters high. So let's start by drawing my little house. All right, house is, well, let's draw it on the other side. House is 4.2 meters high. And what else have I got? I got a power pole. It can just be a big stick. All right, and that's going to be 6.2 meters high. The horizontal distance between the house and the power pole, so this distance here, is 12 meters. Find the angle of elevation from the top of the power pole, so of this point here, from the top of the house, so from this point here. So we want to know the angle going up in here. That's what they want us to find, that angle there, okay? Now, I've drawn my diagram a little funny here because I've put the dimensions on the outside of the house. But really, when it says, that the house is 12 meters from the power pole, that 12 meters is, from here to here, right? The point of the house where we're standing to there is 12 meters, and the height, from as in 4.2, is still from here to here too. It still applies there. So, if I was to draw my triangle, right, so this situation is a little more complicated. If I was to draw my triangle, the base is quite easy. The base is 12 meters. But this height here is a little bit harder, right? The entire power pole is 6.2 meters. But we're not looking at it from the ground. We're looking at it from the top of this house, which means we're already 4.2 meters up in the air, which means the distance from here to here, i.e. the question mark of my triangle, is only an extra 2 meters. We only need to go an extra 2 meters up to get from 4.2 up to the top, which is 6.2. So coming back over here, I'm going to label this one here as 2 meters. And then we're going to use, I've got to find an angle, so I'm using trigonometry. Opposite, adjacent, if we label our triangles. I'm trying to find the angle. So if I'm looking at tan, trying to find the angle, I will cover my angle, and I have opposite divided by adjacent. So we're trying to find tan of theta, which is going to be opposite over adjacent. Opposite is 2, adjacent is 12. Once again, going to take tan inverse 2 over 12. We get 9.46 degrees.